New Chinese AI agent CodeBrain 1 just shocked the AI world by hitting around 72.9% on TerminalBench 2.0, instantly placing it second globally against major labs, and doing it on its very first appearance on the leaderboard. At the same time, ByteDance's Seedance 2.0 has dropped, and it's already generating multimodal, story-driven AI video that actually feels intentional and consistent instead of random visual chaos. On top of that, Alibaba's QuenImage 2.0 is pushing image generation forward with much stronger prompt understanding and deeper creative control. Some people online are even calling it the Chinese nano banana. And researchers have also introduced Fine R1, a new vision model that can distinguish ultra-similar objects, like different aircraft types, using only a tiny amount of training data. Let's start with AI agents. TerminalBench 2.0 has basically become the go-to stress test for evaluating whether an AI agent can actually do things inside a computer, not just talk about them. Even the strongest models still struggle here, with many top systems hovering around the 60% success range. At that level, even small improvements start to look massive. OpenAI recently showed strong results on this benchmark using their GPT-based coding agent setups, reporting scores around 77%, which put them at the very top. Anthropic followed with Claude Opus, landing around the mid-60% range. Then came a Chinese startup called DeepSeek AI with CodeBrain 1, and it immediately took second place worldwide. With scores around 72.9%, it now sits just behind the top spot and ahead of many major competitors. So, what's driving its performance? The focus is extremely practical. Increase the chances that the code actually runs correctly. CodeBrain 1 is designed to stay tightly focused on the task instead of getting distracted by unnecessary information. When it needs details, it pulls very specific code references and documentation directly related to what it's doing. This tighter focus makes its workflow much more efficient, especially when something breaks and it needs to fix errors quickly. It uses something called the Language Server Protocol, basically tools that understand entire code bases. Instead of guessing, the AI looks up real function names, parameters, and usage examples. So, if it's building something like a game bot, it doesn't hallucinate how functions work. It retrieves the exact implementation details and uses them directly. Then comes the error correction loop. When the AI writes code and something fails, it reads detailed diagnostics, checks correct examples, verifies documentation, and adjusts. That loop, write, test, fix, keeps getting tighter and smarter. In smaller test environments like a set of Python tasks, CodeBrain 1 also used over 15% fewer tokens compared to some competing systems. That means faster execution and lower cost, which becomes extremely important at scale. Another key feature is adaptability. The system can actually change its plan while working. Imagine giving it a task in a game like Build a House. It breaks that down into steps: gather resources, clear space, craft tools, and construct the structure. Then it executes step by step. In more complex scenarios, it can even build memory. If a player repeats the same strategy, an AI-controlled characters can remember and adapt, blocking paths, changing tactics, and reacting differently over time. This is where things get interesting. The same company also introduced a system called Membrane, focused on long-term memory for AI agents. Combined with CodeBrain's planning abilities, this creates a much more complete agent system, one that can handle longer, more complex tasks. Now, let's move to something more visible: AI video. AI video has been stuck in a frustrating phase for a while. It looks amazing for a few seconds, then completely falls apart. Creators often have to generate clips multiple times just to get one usable result. That's where Seedance 2.0 comes in, and it's being called a turning point. This model understands how scenes should flow. It supports text, images, video, and even audio as inputs, allowing for much more control. But the biggest improvement is how it behaves more like a director than a tool. Camera movements, like pans, zooms, and tracking shots, feel intentional. Scenes are framed properly, and most importantly, consistency is finally there. Characters keep their appearance, backgrounds stay stable, and the video doesn't collapse into randomness. That's what enables longer story-driven content instead of short, flashy clips. This shift could have major consequences. As one game industry founder pointed out, this will likely cause content inflation. In simple terms, the cost of making videos is dropping rapidly, which means the amount of content will explode. Industries like e-commerce will feel this first. Product videos no longer require studios. Merchants can generate them instantly. In gaming, studios can create trailers and concept previews much faster. And on platforms like TikTok, the real competition shifts from creating content to filtering it. Film and TV workflows may also change. Instead of shooting raw footage and editing later, storytelling, camera logic, and scene creation are happening during generation. Editors may evolve into creative directors who guide AI instead of assembling clips manually. But this also introduces new problems, especially around copyright. People are already using these tools to recreate styles from famous filmmakers, copying expressions, humor, and iconic scenes at a very low cost. This raises serious questions about ownership and creative rights. At the same time, it highlights something important. In a world flooded with AI content, so recognizable intellectual property becomes even more valuable. Now let's talk about AI images. One of the biggest frustrations with image generation has been poor prompt understanding. You write a detailed prompt, and the model ignores half of it. QuenImage 2.0 is designed to fix that. It can handle long, complex prompts, maintain consistency across multiple scenes, and generate high-resolution outputs. Whether it's detailed infographics, stylized artwork, or multi-panel storytelling, it keeps elements structured and accurate. It also performs strongly in image editing, combining photos, changing elements, and maintaining realism. And one standout feature is its ability to render complex text correctly, something older models struggled with. Finally, there's FineR1. This model focuses on fine-grained recognition, telling apart extremely similar objects like different aircraft models. Instead of just guessing, it uses step-by-step reasoning, analyzing details, comparing possibilities, and making a structured decision. What's impressive is how little data it needs. With just a few training examples per category, it can outperform well-known systems in certain tasks. So, across AI agents, video, image generation, and visual recognition, one clear trend is emerging. AI is becoming more structured, more reliable, and far more capable. And this is only accelerating.